Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discuss about the Diels-Alder reaction, that is a cyclization as well as oxidation reaction. So these kind of the reaction we have discussed in our previous lectures. So let us re-explain once again Diels-Alder reaction, that is a cyclization. What do you mean by that? Diels-Alder reaction. Diels-Alder reaction. Diels-Alder is a scientist name. He discovered the reaction where the dine and dienophile react together, and that reaction also known as 4+2 cycloaddition reaction. Here we are generally discussing the reaction of anthracene. As we know that anthracene, there is a 3 fused benzene ring come together, that is known as anthracene, and that anthracene is an aromatic compound that fulfill all the criteria of that aromatic compound, and that's why anthracene is a aromatic compound. But the reactivity of that anthracene is greater over the naphthalene, and even though it is an aromatic compound, it can also undergoes addition reaction, and that's why that 4+2 cycloaddition reaction given by the anthracene, and the addition reaction were taking place at 9 and 10 position, and the resulting compound is formed, that is a 9,10 dihydro anthracene or 9,10 alpha beta succinic anhydride. So that is a product which we are getting there. In oxidation, and oxidation also occur at a specific position only, 9 and 10 position, which is a more reactive, where the oxidizing agent like chromium trioxide, it is a more oxidizing agent or strong oxidizing reagent employed there, and the resulting compound obtained will be the 9,10 anthraquinone. So far these are the reaction we have described or we have learned in our previous lecture. So today what we are going to discuss or what we are going to learn, that is Friedel-Crafts alkylation reaction. As you know that, everybody knows that. Do you remember Friedel-Crafts reaction? Yes, Friedel-Crafts reaction where in an aromatic compound R group or acetyl group is introduced in an aromatic moiety, and that kind or that type of the reaction are known as a Friedel-Crafts reaction. Generally Friedel-Crafts reaction are classified into two types. One, when R group is introduced in a aromatic or R group is attached to the aromatic compound at corresponding position or at a relative position, if there is a substituted aromatic compounds are there, which is known as Friedel-Crafts alkylation reaction, and another one is known as, second one is known as a Friedel-Crafts acylation reaction. Acyl group is introduced in the aromatic moiety, or acetyl group is attached to the aromatic compound with respect to the corresponding position. So just here remember as a two type of the Friedel-Crafts reactions are generally occurs. One Friedel-Crafts alkylation reaction, another one is called as a Friedel-Crafts acylation reaction. That's the thing everybody I know. Clear? Let us see here Friedel-Crafts alkylation reaction. First one, the Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation. Here, as we know that anthracene react with strong base such as sodium in presence of ammonia and form disodium salt which react with alkyl halide, as we know that RX, and gives a 9,10 dialkyl anthracene. That is a speciality of that Friedel-Crafts alkylation reaction. In general, in case of the aromatic compound, let us see simplest aromatic compound is a benzene here, suppose, and it will be treated with RX in presence of AlCl3, Lewis acid. The generally reaction takes place or occurs that gives monosubstituted alkene, and that RX is nothing but as a alkyl halide, and this is a Lewis acid catalyst. Without Lewis catalyst, there will be a no Friedel-Crafts alkylation is possible. And once that alkyl group introduced, as we know that it is a electron releasing group, so it becomes as more reactive than the benzene, and therefore there is a formation of the mixture of the product takes place. It is further reacted with another alkyl halide, and that gives rise to ortho product, ortho isomer, meta isomer, and the para isomer. These are the mixtures generally obtained, and that is a polymerization polyalkylation we can say. That is one of the limitation of that Friedel-Crafts alkylation reaction. But in case of the anthracene, you can preferentially, you can exclusively prepare the compound. Let us see here the starting compound. What they have taken is the anthracene, because we are discussing about the reaction of the anthracene, and therefore the starting material should be this one. And this, when it is treated with two metals of, that is a sodium in presence of ammonia, NH3, they react together and it gives rise to the mixture that is like this. The reaction takes place between this. We are getting NH2 and NaH, sodium hydride, but this one is a very, very strong base, and it is known as a sodium amide. Sodium amide. It's the name of this compound, sodium amide, and which is act as a strong base. But in this case, what is going to happen? The intermediate which we are going to get over here, see here, I am showing this is the intermediate which we are going to get over here, that I am showing over here, this one. Here I am showing that hydrogen atom and then Na plus, and here maybe as minus charge. Same thing, hydrogen atom along with that sodium metal, and here is a negative charge on it. Now the Carbanion means what? When the carbon atom carries negative charge, that species are termed as a Carbanion. So here the Carbanions are formed when this is treated with 2 moles of RX alkyl halide. This is a disodio salt. This is called as a disodio salt. Disodio salt we are getting, and that disodio salt further reacted with alkyl halide, and the resulting compound obtained will be this one. You can see, you can observe this structure carefully. Here the first ring, second ring, third ring, where here is a R group is introduced, here also as a R group is attached, and this is known as 9,10 dialkyl anthracene. This is a 9 position, this would be the 10 position, and therefore the R group which are present at 9 and 10 position, 2 are there, and therefore 9, 10 dash dialkyl anthracene will be the product obtained, and this is known as a Friedel alkylation reaction with anthracene. Now let us move on to the next reaction, or you can take an example over here. This is a general reaction which I have shown over here. Now let me give some other examples so that you can clearly understood this Friedel alkylation reaction. Let us take first compound, which is anthracene, which I am showing over here, this one. Now it will be treated with Na in presence of NH3, sodium metal in presence of ammonia. It forms the salt like this. This is a salt which gives over here minus charge, Na plus you can write over here. Here is a hydrogen atom, you can write here minus charge, Na plus, because metal always carries as a positive charge, and therefore the other part, this is a intermediate which we got, that is called the disodio salt obtained after the treatment of sodium in presence of ammonia. Now when it is treated with CH3Cl methyl chloride, 2 moles of methyl chloride will be used over here, then heating is required, and so that the reaction takes place easily, and we are getting the product, this one. The methyl group comes at this position, another methyl group, and then you can put the alternative carbon-carbon double bond, so that that molecule becomes aromatic in nature, and therefore you can call it as a this is a 9 and 10, 9,10 dimethyl anthracene will be the product obtained in this reaction, in this case. Understood? This is one of the example which we have seen over here, how we are getting. Just remember, this is the anthracene starting material, anthracene and then treated with the sodium in presence of ammonia gives rise to the salt and 9,10 dimethyl anthracene would be the final product obtained with high yield, or we can say atom economy. Now let us move on to the another example, that is Friedel-Crafts acylation reaction. That is this one is a Friedel-Crafts alkylation reaction. Now we can say Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction means the reaction would be carried out in presence of RC double bond OCl, that is a general, and in presence of AlCl3, that is Lewis acid catalyst, and benzene will be used as an solvent. So anthracene on acylation by acetyl chloride in presence of AlCl3 as a catalyst and benzene as a solvent gives 9-acyl anthracene. That is a specific reaction, specific product or the desired product obtained in this case, 9-acetyl anthracene. So now this is also Friedel-Crafts acylation reaction, means RC double bond O, this group is introduced at 9 position, or RC double bond OC group is attached at 9 position in the anthracene. That you should remember while predicting the product on this particular reaction. Now here Friedel-Crafts, let us see the starting materials once again. This is a starting material which we have taken here, is this one. This is a starting material, as we know that here, and now this will be treated with RC double bond O Cl in presence of AlCl3, that is a Friedel-Crafts alkylation reaction, and where C6H6, or you can call it as a benzene. Benzene is used as an solvent over here. The product which we are going to get in this particular, the starting compound, we know that it is a anthracene, which is a starting material which we have obtained in this particular case. Now what do you get? You are going to get the product, this one. You can observe this product carefully. This is the compound which I am showing over here. Here is a C double bond O R. The acetyl group which is introduced or attached as 9 position, therefore we can call it as a 9-acetyl 9-acetyl anthracene. 9-acetyl anthracene would be the product obtained in this reaction. Now let us see one more example over here. I am taking as a starting material once again this one. This is a starting material which is nothing but as a anthracene, which is a starting material taken, and then that will be treated with CH3 C double bond O Cl acetyl chloride in presence of aluminum chloride, and benzene used as an solvent in this reaction carried out to get the product which is getting is this one. You can see clearly here. I am showing this is where C double bond O CH3. Here is the acetyl group is introduced at this position, and this is a general acetyl group. Here you can call it as a 9 acetyl anthracene. Anthracene, which is a product which we got over here. So I think these are the some of the important reaction of anthracene. We have studied one by one with their detailed description, where the groups are introduced, at what position in anthracene are more reactive or other one. So that are the reaction which we have studied about anthracene, and whatever the nucleophilic substitution reaction regarding polynuclear aromatic compound, that we will discuss separately after completing the most readily electrophilic substitution reaction as well as some of the addition reaction, even though they are showing here that we have seen some of the nucleophilic substitution reaction regarding that naphthalene we have considered, but some of them remaining nucleophilic substitution reaction we may learn in upcoming lectures. But here and tomorrow we will discuss, or we will learn about the heteronuclear aromatic compound. How do we define heteronuclear aromatic compound? Hetero itself indicate as a different. Hetero, the word hetero means different. In case of naphthalene and anthracene, where we have seen only carbon atom are involved in the ring, and they follows the obeys rule or aromatic character. In case of the heteroatoms, specifically 5-membered ring and the 6-membered ring, generally 5-membered rings are pyrrole, furan, thiophene, and 6-membered heterocyclic compound, which is pyridine, that we are going to study, because the name of this polynuclear and heteronuclear aromatic compound, poly means many, and there are two compounds at T.Y.B.Sc level we have learned. One is a naphthalene and another one is anthracene, whereas under the heteronuclear aromatic compound, where we are going to see 5-membered ring, are the 3 main common rings which are the more aromatic than the benzene, and how they readily undergo as which position they shows as the electrophilic substitution reaction more readily, that we are going to discuss with the help of showing as a resonating structure or the canonical structure, and from that we going to learn how they shows the electrophilic substitution, whether they are take place or the incoming group, whether attached to 2 position or the 3 position, that we are going to discuss in our next lectures. And pyridine is one of the ring which is a 6-membered ring. In the ring, nitrogen atom is involved and rest are the carbon atom, but which is aromatic in nature, but that aromaticity is less as compared to the 5-membered ring heterocyclic aromatic compound. Why this is so, and at what position electrophilic substitution as well as nucleophilic substitution reaction, showing at what position, that also we are going to discuss in our upcoming lectures. I think with this, let us stop today here. Remaining we will discuss, we will learn in our next lecture. Till then, have a nice day. Thank you.